Started. So it seems like, well, how's everybody's project going? I guess that's where we can start. Hmm. Okay, let me rephrase that. What problems are you having? Can you guys hear me? Okay, cool. Yeah, that's actually what you are supposed to be doing. We encourage you to use the case statements. That was why I included it in the tutorial. Encourage you guys to use it. So it seems like a lot of you are having um, difficulty dealing with negative numbers. Is that correct? Well, I suppose you could do that as long as you are getting the right output on the timing diagram that corresponds to the correct numbers. Or, the ones being on in the right place on the display. I personally think it's easier to see it in binary. I mean, yeah, it takes a minute to type, but that's what the old copy paste is for. But yeah, whatever way you want to output it is fine. We'd prefer binary, but as long as it is equivalent, um, I suppose you could do it in just about whatever you want. Well, one question that I've noticed a couple times in the forum is how to represent the negative numbers. And we do want you to be able to represent those. So you guys have learned about uh, signed numbers, right?
Hi, this is Josh. You basically use just like an extra bit, right? To tell like, okay, this uh, binary, if it has like the extra bit that's like a 1 or something, this is a negative number, correct?
Yeah, that's using a signed number. So basically, what this is going to be is it's a 4-bit signed number, so you're really going to be able to actually use only 3 bits in your computations, where that last bit, or I guess the first one is depending on which way you look at it, but uh, in a linear fashion, the one that comes first will be your sign bit, so that will tell you if it's positive or negative. Here, we'll just do something simple here. Let's do, I don't know, sounds good. Okay, so, uh, overflow, yeah. If I recall correctly, we use the same syntax for that addition, with that overflow or underflow. Okay, so far so good. So, so is everybody pretty much understanding how to implement that select? Everybody kind of get what's going on there. That would not be represented as overflow. We want to actually be able to represent negative numbers, and that's where this signed comes into play. So, for example, C is our 3-bit numbers. If this was 0, 0, 1. That would equate to a positive 1. So if we said like 1, 0, 1, then we would need to perform a 2's complement on it, because this represents a negative number, because this first bit is a 1. Now, here that 1 is means negative, so let's see, this would be 1, yeah. So this is negative, what, 3? Yeah, negative 3. So we do want to account for negatives, but I believe that it can be done pretty much like this. Let's give this a try. So it's 1, 2, 4, 6, 2. Gotta go. Um, oops. Yeah. Go. Right. Well, that rollback, or seeming rollback, is just it displaying a negative number. So pretty much anything from hold on a second. Let's take a look here. Okay, cool. So this should work. Yeah, the rollback is just it showing negatives. Because you're only going to be able to compute up to, I think, let me see here. So you want to be able to compute up to 7. Uh, 7. There's that fourth bit in there will be your sign bit. So yeah. So no, unfortunately, that would not be overflow. Overflow would be if you're adding anything. Say you're adding this number and this one. That would result in an overflow because that would carry over to your sign bit, which is no good. So does that answer your question at all? Yeah. Right? Well, using signed inputs is the only way to represent negative numbers. I suppose we probably should have been a little more clear, but I mean, I figured you guys would pick it up because it was, I think you guys learned that, what, like last week or this week, right? The same way, because, yeah, just do the same thing you're doing. Um, no, because so the positive values that you'll be able to represent will be from 0 to 7. So then from 8 to 15 are basically the representations of your negative numbers because they have the 1 on that fourth bit, so on that sign bit. Everything from everything here will be positive, and then everything from the would be your negatives in your result, of course. I believe so, yeah. Let me jot that down. Looks like it should be E. Well, let's see. I think let's check the old test bench here. Well, I suppose you could just encode it that way, but let's see. Alright, so anyway, well, let's see, when I ran my 1 minus 2, that would get 15, because negative 1 would be represented by 1, 1, 1, 1. Because then when you perform the 2's complement on it, you get 0, 0, 0, 1. I mean, I suppose, just like in any system, you could hard code the values if you know exactly what you're going to get, and it's, as limited in scope as this one, and we're only using 4 bits, so you can almost, count that off on your fingers. That is true. Well, in that case, you could um, maybe limit your input values. Like figure out what actually is, or what would result in an over underflow, and just have a check to see, if the inputs are below this, are within a certain range, and let it through. Otherwise, raise the flag.
We only running one display or multiple displays?
Oh, I'm running two right now. I have a very small monitor, so if I want to see what people are typing, and oh yeah, you guys can't see that. Oh geez. How can I do both? Can I do both? Um, oh god. Oh, yeah. Yeah. Oh yeah, that's you. It's terrible. Oh. Well, you guys can see all the chat stuff, right? I'm assuming that's what you were referring. Okay.
I mean, like the 7 segment display, like, do you want us to run multiple ones or just the one?
Oh, wow. I thought you were talking about something totally different. No, just one ought to be fine because since we're only using 4 bits, that can be fully captured on one.
Play the negative though. If we were only running one.
So is that you cut out there?
If we only running one 7 segment display, how do we display the negative part to that? Like a negative number.
Oh, that would be your fourth bit. So yeah, 0, 1, and 2, or 1, 2, and 3, whatever. But these are going to be the 3 bits that you're actually using as numbers. Whereas the this fourth bit here, this is going to be your sign bit. So this will tell you whether it's positive or negative. So like I was saying down here, these would be all the values that correspond to negative numbers on the 7 segment.
Right. Like if we broke down a 7 segment display to like from A to G,
Yeah.
if we have a negative number, um, how do we encode that to also display right side with that number on a 7 segment display?
Oh well, you're displaying everything in hex,
Okay.
so yeah, you won't actually be able to put like a minus in front of the number, but just give its hex representation of the binary. So
Okay.
basically everything like 8, 9, A, B, C, D, and E and F are going to be negative numbers. No, it's gonna look a little weird, but since it's hex, it's means different stuff.
Okay, because earlier you were talking to Frank, and you said output our decoder with a hex rather than binary. So
Well,
I
right. So let me see. That might have been a bit confusing. So you want to encode everything in binary. So um, like here in the Verilog, when you're doing your decoder, using to binary, but what is actually being displayed on the display will be hex. So like your binary output, like say, let me see. Hold on, okay. Okay, so let's say number one, which would be output would be one. Oops, that would correspond to let's see, uh, yeah, sorry, the computer's being slow. I think the A starts at the top of 7 segment, right? You know, there's the brain part. All right, well, I'm just going to do this assuming that the A starts at the top. I briefly forgot, and my computer is taking forever to load. So we say it's 0, 1, 2, 3, corresponding to the spots on the display. Does that make a little more sense?
so we're basically taking from what's from the adder. It's a binary number, and then
Right,
we're decoding it, and then that outputs a hex. So that's what you're saying, right?
right. So yeah, I suppose I used a example that would work anywhere. Okay, so let's use a more hexy number. Let's say like 10. Okay, so that would be okay. Cool. A is the top. So 10 would be A, which would be let's see. Mm, 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 A, C, D, B. That comes out to a capital A. Like like that. So yeah, I guess it's actually yeah, uh,
Al, I don't mean to interrupt, but that's not really making
oh
any
yeah,
sense.
no.
Um, the two's complement isn't covered until chapter 4 in the book, which has not been part of the reading assignments. But aside from that, you're saying that the hex is supposed to be represented uh, by the negative numbers, or the negative numbers are represented by the hex, I should say. But if I have input A and input B and I add them together, you're saying that I should get A, right?
Here, if you add A and B,
And they're both 5. I
oh yeah,
should I should display A, correct?
that would be an overflow because you only actually get 7 numbers.
So we're actually only using 3 bits.
Yeah, the fourth bit is the sign bit.
Okay. Now, that's kind of where I have an issue because how can that be assigned when that's not until page 202 in the book, which is nowhere close to what we've been studying yet.
Okay, so you guys have not covered
I mean, we haven't even
sign
gotten
bits.
anywhere. I'm familiar with two's complement. I've done it before, but not in this class.
Oh, okay.
Um,
I was going over this, when we were making this project, I was under the impression that you guys had already had that.
I'd be willing to bet everybody in this group would clearly say they haven't been over two's complement yet.
Okay, well, let's see. Let's see. I think ASIC World has a lot of pretty good examples. They're a little more complicated, though. I don't know. That a lot of those examples can be done a lot simpler than you see on that site. But let's see here. What else?
We're taking like the two inputs, one and
Mm,
B. The B inputs is going to have, or basically we have 3 bits from A and B. It's going to have 3 bits for the numbers, and then the very front bit, the very left bit, would probably be what our sign, right? So either a 1 being a negative number or a 0 being a positive number. And we're just basically taking that into our adder, and we're just algebraically adding those together. And then we're outputting that number and the sign to our decoder, and that will use the hex to display out what we have.
right. It will be displayed in hex, but everything is encoded in binary. Or at least I find that's the easiest way. I mean, it's possible to represent, this in hex, but I don't know. I personally think it looks a lot cleaner in binary. You can pretty much see which segments are on and off instead of having to do an extra conversion in your head.
Use statement, you pretty much tell it that these are the set stuff you need to select from, right? So wouldn't it be a little bit easier to say, okay, if this equals -2, then this goes this hex, and then if it's like overflow, then it's basically you just use this only.
I think I missed the end of that. I think it cut off right before the end of the sentence.
Sorry, I have bad wireless. So we're basically taking like from our decoder, like I'm using the use case statement.
Right.
So I pretty much have determined selection there. So if I can just basically do that and tell it, okay, use that A through G to display this number. And then I can just get to the very end and say, okay, anything that's not this, it has to just be overflow.
Right. Right. Yeah, and there is still you can still have that overflow, or underflow being there, and from what I know, it will like if you're trying to add or subtract numbers that are outside of the range, then it'll just raise this. So luckily, Verilog does a small part of the work with that. So that's nice.
But it's going to raise that as soon as you subtract and go into your negative numbers.
Let's give that a try.
And that's the problem, because once that's raised, if that's why I'm saying that doesn't make sense with what the assignment is really asking for.
Alright, so if we go, let's say that.
Post something on the chat, by the way.
Let's see, as for the resources, geez, I think I mostly just read the book a lot. And for Verilog stuff, yeah, the ASIC world was pretty good, and geez, yeah, it's been a while since I had to look that kind of stuff up.
But
Yeah, honestly, just Google.
the two's complement is not covered with what we've been assigned to read so far. I don't even know if we're even going to get that far in the book. It doesn't even show up till page 202. That's in chapter 4.5, 4.6, something like that. We're on chapter 2 and 3.
All right. Well,
Post like additional like information about this project for other people to know who are not
And
on this.
yeah,
can,
I might talk to Dr. Sahoni and see about maybe just scrapping this sign thing, because yeah, yeah, I thought that you guys had already covered this. Yeah, that I think sure that yeah, because I mean, you guys don't know it yet. You haven't learned it yet, so you shouldn't be responsible for that. So yeah, I'll talk to him after this and put up an announcement. What I'm probably going to suggest is that we do it to where the subtraction is, let's see, type it out here. I think we'll say, or I'll suggest subtract A, oops, A from B, if the B greater than A. No, I don't. Yeah. Yeah. And I suppose anything under 0 we would say is a underflow. I guess just a nice little tidbit of information. I hope that at least some of the decoding questions were answered. But yes, that we add in the description. I'll find an announcement. You guys shouldn't have anything that you don't know. Yeah. So negatives aside, are there any other questions?
Good opportunity to ask, guys.
Alright, so I suppose I'll just go over some of the basic concepts that I suppose are covered in this project, and I guess make questions that are more specific. So there's the just basic Verilog syntax, so you're all kind of what goes in there, how information or the data is manipulated that way. That, I guess say something if you're not clear with it. Alright, so yeah, I'm just going to keep talking until someone interrupts me. So the next is, let's see, you're assigning your inputs and outputs. That was kind of basically covered in the first project. And then I think the real kickers here are setting up your decoder and manipulating the first output of your arithmetic function. And the other one was selecting which one to which operation to use. So I presume everybody's fairly clear on that. I think I covered just in the tutorial. I didn't really do much about the select bits because I don't know. There's just really not a way to show that without completely giving it away. So I try to give you guys some hints though.
Didn't you just say like on the first bit that you see, have that as the negative or positive, and you just adding those together, like algebraically?
Is this
That'd be a
assuming
good. That would be a decent hit, right?
like for the select bit, or like the addition or subtraction selector?
Oh, it's a select bit like addition or subtraction? Because I was thinking like earlier, you were saying like the extra bit on the third bit of numbers there for the inputs for to tell whoever that's negative or positive.
Hmm. So, well, I mean, at this point in time, I'm going to kind of try to get away from those negative numbers. 'Cause, yeah, if you guys haven't learned how to, represent those even and all that, then you, you shouldn't be held responsible for that in a project. Let me see. Okay. So yeah, this is basically just like a generic multiplexer that you're supposed to make. But yeah, if you were sending this out like as a string of some sort, you might, have somewhere in that string, and that would, tell you which operation you're doing. Keep an eye out for the announcements. I mean, obviously, I guess you guys get them in the emails, but yeah, I'm gonna talk to Dr. Sahoni about um, doing away with the negatives and just keeping it positive.
All right. The way I understood it to be, Al, was that we had 4 bits
Mm-hmm.
for A and 4 bits for B, and that gave us a total of 16 possible numbers. Um, if we added, say, A was, I don't know, 12 and B was 10, then that would count as overflow. Uh,
Correct.
if you subtracted uh, 10 minus 12, okay, that sets the underflow bit. And I thought, and my understanding was that that would also be considered overflow since we hadn't gotten to signed and unsigned numbers yet.
Yeah, that is correct.
That was my interpretation of it.
Yes, and negatives aside, that is the correct implementation.
Okay, all right.
So yeah, I think it seems like it didn't seem to know what was going on, and yeah, I didn't realize it had not been introduced in the book yet. I thought it already had. So yeah, like I said, I'll talk to Dr. Shahani and see about doing away with the negatives. Alright, well, do you guys have any other questions? If not, I have got some work myself to do. Alright. Alright, so I will take that as everybody's good for now. But yeah, if you run into any problems, keep posting on the forum. I'm trying my best to keep up with that. Or shoot me an email if it's a more specific problem. No problem. Thank
Yeah, thank you.
Yeah, sorry about the confusion with the negatives. Yeah, I'll fix that.
Okay, well, that's, no,
All right, have a good night, everybody.
thank you.
Yeah, no problem.